Hi, welcome to FFMPEG tutorial. This video explains how to use FFMPEG filter API functions. So let's start a Qt widget application in Visual Studio. Let's name it as video encoder. We'll come to encoding process later. And in the UI form file, add a push button. Let's change the name of push button as a start button, as a start. Declare the push button click event. I will add two classes to this project. One is FFMPEG class where input processing will happen. So let's name it as FFMPEG. Includes header files and CPP files. And another class to write the functions for filter initiation. So let's name it as filter. Filter class include the necessary FFMPEG library functions. So define a filter structure. It's not a class, it's a structure we are defining. So we'll use two filter contexts, one for source and one for sink, and filter graph also. So three functions we'll use: input video filter and output video filter configuration, then filter initiation. So we'll declare the functions, include the header files. So the arguments are the filter string, which gives the details of the filter we have to use, and maybe frame. So allocate the filter graph. Now we'll parse the filter string. And after parsing, we'll define the input filter and output filter. Let's say we are using the scale filter. So it will have one input pad and one output pad. So we have to connect the source filter to scale filter, then scale filter to the sync filter. So after that, configure the filter graph. Now we'll initiate input video filter. So here the current filter will be the scale filter in our example. So always video input will be a buffer filter. So initiate and create a buffer filter with the following parameter: video size, which includes width and height, the frame format, frame time base, frame rate, and aspect ratio. Now assign a name to the filter as input and create the source filter using the buffer filter. Now we have to connect the source filter to the scale filter in our example. So using AV filter link, connect source filter to the filter context of the current. Now we'll define the output filter. So for video, always output will be buffer sync filter. So let's name it as output 1:0. Now get the filter, buffer sync filter, and create that filter. So here we create with the sync filter. Now we'll write a format filter so that our display of video will be easier. So I'm converting the format into YUV420 plain format. So create the format filter. Connect this format filter to the output of the scale filter. So here the last filter will be our scale filter in our example. So this scale filter is connected to format filter. And the format filter will be connected to the buffer sync filter. So always the output will be buffer sync for video. So here we connected the format filter to sync filter. Now we'll write input processing functions in the FFMPEG class. So include the necessary header files. include an SDL2 library for display the frame or video. So in the class, we'll have a format context to hold the details of the media. For display, we'll use an XML renderer and texture, and a codec context for decoding. We'll take an instance of the filter structure also. So our main API is open input. So let's define the open input functions and do the necessary header files. So input is the media file. Allocate the context, initiate all its buffer. Open the media file using the API function AV format open input. Catch the error. After opening, find the stream information in the format context. From that stream information, find the video streams. Now, using that video stream, open a decoder. So first, find the decoder using the product of the input video. Using that product, allocate product context and copy all the video parameter to the product context. Open the product context. Now we'll read the packets from the media file. So first we'll define an AV packet, unique pointer, so that it will manage the memory. I use the AV read frame. So on each iteration we'll get a packet complete video frame. Check whether it belongs to a video stream. If it is, we will send the packet to video decoder using the function AV codec send packet. Now to receive the frame from the decoder, we use the function AV codec receive frame. So for that, define an AV frame as unique pointer and receive the frame using AV codec receive frame. Put in a while loop so that all the frame will be received before feeding that packet to decoder again. Now the obtained frame will give to filter for initiation. So let's say we are using the scale filter. The parameter is 360 x 240. So initiate the filter using that frame. After initiating, send the frame for filtering. So use the function AV buffer source add frame to the source filter and receive the filtered frame from the sync filter. So we'll define a filtered frame as a unique pointer. So use the function AV buffers get frame and get the filtered frame. Using that frame, let's initiate the SDL functions for displaying the video, and after initiation we'll write the code for displaying the video. So initiate SDL. First initiate the video components of SDL, then create a window with the name as a video player. At the position X and Y, width and height, then create the renderer using that window, then texture using the renderer. Now define the function to display the frame. Create an XL rectangle. And update the YUV texture. So YUV texture means the frame should be in YUV 420 planar format. So in the filter we used format filter also. Now clear the renderer, then copy the texture to the renderer. Now display the frame. Okay, let's test the project. So we are getting 360 scale version. Let's change the scale parameter. Hundred is to 1000. So here 100 is the width and 1000 is the height. Let's change 1000 with the square frame will get. Let's change into HD resolution.